So from there, let's go look at what it is we're supposed to be doing next. So an angle in the Cartesian plane is in standard position if its vertex lies in the origin and its initial arm is on the positive x-axis. Okay, you know this. This is simply uh, how to draw an angle in standard position. We talked about this. Now I'm going to add something new to it today, though. Okay, it says let P xy, so P is a point, be a point on the terminal arm of angle theta in standard position. The side opposite theta is y, and the adjacent side is x. Okay, where are you getting that from? Let's just go back and just look at this quickly. Imagine, so this is very much what they're talking about, right? So here's point P. You can see it has an x coordinate and a y coordinate, and it has a radius. And specifically, in my question, I've designed the radius to be 1, so that the radius is 1. You'll see why I did that a little bit later. If you imagine a little triangle here, okay, so let's make a more obvious one. Let's pick 60 degrees because we know that one. Okay, think about this triangle with the dotted line as a height and this part along here as the bottom. From the point of view of 60, this would be the adjacent and this would be the opposite. Now think about this from the perspective of the point. This would be the x coordinate and this would be the y coordinate. So we come to this idea that if you draw your angle, okay, and on your page I would definitely recommend you just take a second to draw this. Draw a straight line going down from here to here. Okay, a vertical line from there to there. That is your opposite, and its length you should be able to see is y. If you draw another line from from here to here, okay, so from the middle over to there, that is your adjacent and that is your x. So this gives us a new way of understanding trig ratios, which is that in any situation, right, in the any angle, you can think of the angle as having a point. The point is at the edge of the radius, and it has an x coordinate and a y coordinate that correspond to the angle it comes from. So look at what it says here. The primary trig ratios are sine theta is y over r. How did they get that? Look if you were looking from this angle right here. The opposite would be this side, which is y. The hypotenuse would be this, which is the radius of the circle. Similarly, cosine would be x over r, so that would be the x coordinate here over the radius, and the tangent would be the y coordinate over the x coordinate. Now, what is amazing about this is that it actually tracks the cast rule. Let's watch one more time here. My x and y coordinates in the top quadrant are both positive because sine, cos, and tan are all positive. Now look in quadrant 2. Cos is x over r. Well, my x coordinate is now negative, right? In quadrant 2, my x coordinate's negative, so that's why cos is negative. My tan is y over x, but y is positive and x is negative, so tan overall becomes negative. Sine, on the other hand, is a positive y over a positive r. R, as the radius of the circle, is always positive. And so sine remains positive in quadrant 2. Move into quadrant 3. Both the x and the y coordinates are negative. The y coordinate makes sine negative. The x coordinate makes cos negative, but both of them being negative make tan a positive because you have y over x and the two negatives cancel. Finally, in quadrant 4, your x coordinate's positive and your y is negative. A negative y makes tangent negative and it makes sine negative, but the positive x keeps cos positive. Okay, and this is something you can really use to help remember the cast rule, as well as do a slew of new questions that you couldn't be able to do before. So here it says each point lies on the terminal arm of an angle in standard position. Draw a sketch, determine the value of r, determine the primary trig ratios of angle theta, calculate theta to the nearest degree. Okay, this is a guaranteed question you're going to get. Okay, this is like the big skill from today, and this unit in general is a really important skill to have. So how do I do this? Okay, let's just write down everything we know. We know that x is 12. We know that y is 5. That's it. That's all we've got. Okay, so let's go draw this and see what it looks like. So I'm going to make a point called P, and it's located at, sorry, I guess an equal sign would help. P is located at 12, 5. Now you can imagine how to draw this, right? You would draw a point in the middle. You would draw a point on the positive x-axis, and then you would just make an angle BAP, and the angle is 22.62. Okay, great. So GeoGebra can figure this out. How do we figure this out? Okay, let's get rid of this and get rid of this. So far all we know is where this point is and where this point is. But we also know we have a point at 12, 0. We can make a right triangle, right? If we go segment AC and segment CP and segment AP. Right? You can make a right triangle here. All you have to do is wherever your point is, draw a vertical line straight down and then connect it back to the origin, and you'll always be able to make a right triangle. Right? Now, what do we know about this thing? We know that F and G have lengths of 5 and 12. What we don't know is the radius, right? So imagine this is a circle, and this h is the radius. How do we get the h? So let's begin with a really important equation. R squared is x squared plus y squared. Okay, that is always true in these questions, because to think back to this, x and y are points on a circle, and this is the equation of a circle. So this statement is always true in these questions. So we go r squared equals 144 plus 25, r squared equals 169, r squared equals 13. Now, you could write plus or minus 13 and you reject the negative, but r is always a positive number, so you can just keep the positive. I'll just write in brackets, only keep the positive since r is a radius and therefore a length greater than 0. Okay? So you can't take a negative radius, so you're always concluding that r is a, sorry, not r squared, r is 13. Now, how does this help us? This helps us because 12 over 13 is equal to cos theta. Okay. It also helps us because 5 over 13 is equal to sine theta. It also helps us because 5 over 12 is equal to tan theta. Okay. Now, you can now go to your, so it says, okay, so draw a sketch. So we did that. Determine the value of r. We did that. So the sketch, I guess, technically, whatever. I mean, I'll trust you to draw that based on what we have before. By the way, if I make a circle with point O and radius 13, you can see how what they mean by radius, right? It's like the point P is at the edge of a circle, and its x and y coordinates are the sort of length and height of a related triangle. Now, so what's theta? Now you have your choice of what to do here. You could work with any of these. You could go theta is the inverse cos of 12 over 13, or you could do theta is the inverse sine of 5 over 13, or you could do theta is equal to the inverse tan of 5 over 12. Just to quickly demonstrate this, let's just go ahead and do this. So I'm going to do inverse cos 12 over 13. It tells me the angle is 22.66. Inverse sine 5 over 13, it tells me the angle is 22.62. Inverse tan 5 over 12, it tells me the angle is 22.62. All three of these are obviously unnecessary, but if you do all three of them, you obviously you'll be very sure that what you've done is right. You have 22.62 degrees. Okay, so it says calculate to the nearest degree, so we'll just round it to theta. Is there a quick way to write theta? Okay, slash theta. Well, I should have guessed that. 23 degrees. Okay, so that would be theta to the nearest degree. So determine the primary trig ratios for theta. We did that. we figured out cos, we figured out sine, we figured out tan, and then we used one of them. You don't need to use all three. We used one of them to figure out what the angle was. Okay. Now, in this second question, I'm going to leave a bit open here because I want you to explain something to me based on, we're going to do the exact same method, but we're going to hit a snag. And I want you to try and think about what this snag is and why it happens. So let's write. Let's start. Let's do the same thing we did before. We know x is -3, y is 4. We know r squared is -3 squared plus 4 squared. So r squared is 9 plus 16. So r squared is 25. And therefore r is 5. Again, you reject the negative, but you don't have to write it for this unit. It's fine. R is 5. Okay, now this tells us that so let's do it in the other order. So sine theta is equal to 4 over 5, right? Because sine is the y coordinate. Cos theta is equal to -3 over 5, and tan theta is equal to 4 over -3. Okay, so far so good. We were asked to find the radius. We got it. To draw a sketch again, like I'll trust you to draw a sketch, but just so you can see what it would look like. Let's just go back here and quickly draw it. Okay, so again, I'm going to draw a point. A equals 1, 0. O equals 0, 0. P equals -3, 4. Okay, so the angle is, so then I draw angle AOP, and the angle is 126.87. Now again, we don't know that. We used GeoGebra to get that, but just for your picture, just so you have a picture, it does say draw a picture, so snipping tool. Okay, so something like this. Okay, and there's our diagram. Now, here's a problem. So draw a sketch, we did. Determine the value of r, we did. Calculate the primary trig ratios, we did. Then it says calculate the value of theta. Okay, so according to what I did last question, let's just copy paste what I did last question. Just probably speed this up a little bit. Okay, according to what I did last question, I could just do this. Let's just change this to sine. I should try and keep it in order. All right, last question I could. Now, I could inverse sine, 4 over 5. I could inverse cos, -3 over 5. Or I could inverse tan, 4 over -3. Okay? So no big deal. I take any of the trig ratios and I can inverse them. So let's see what happens when I do this. Okay? So let's write, let's just we'll do it in a table here. So let's say, let's work with this one. Okay, fine. You'd think it would just let you pick the part you wanted. Okay, forget it. Work with sine. Work with cosine. Work with tangent. Okay? If you work with sine, what do you get? So let's go back to GeoGebra. Arc sine 4 over 5. It tells me the angle is 53.13. Okay? Let's say I work with cosine. Inverse cos, -3 over 5. It tells me the angle is 126.87. If I work with tangent, inverse tangent 4 divided by -3, it tells me the angle is -53.13 degrees. What just happened? How can it depend which one I pick to give me the right answer? Look, sine told me it was one thing, tan told me it was something else, and cos told me it was something else. which one's right. Now I happen to draw it with GeoGebra, so I know cosine is right here, but what are the other two functions doing? I want you to think about this, because if you can get this, if you can understand what just happened here, the hardest thing in this whole unit just clicked for you. If it doesn't click for you right now, this is not the only time we're gonna talk about it. Okay? But I guarantee this will be your communication question. I always ask this. Ask it again in grade 12. How is it possible that we are looking for one angle and yet we get 3 different answers? How are those answers helpful? What is it trying to tell me? And why are they not the same? Okay? This is really important. We will go over this, but I want you to sit with this. Just take 10 minutes after this lesson is over and ask what happened up there when he did inverse sine. Everything was right. There's no mistake here. Everything here is perfect. But why are tangent and sine not giving me the answer? Okay? Now to finish up for today, we're just going to go to a last couple of ones here. It says for each angle theta, predict which primary trig ratios are positive. Determine the trig ratio to the nearest hundredth. Okay, so, I mean, again, this is really silly. All you have to do here is just figure out the angle. So, theta in the first question would be like saying, if I went a whole 180 and then backed up 15 degrees, I would be at 165. And that is what the answer is for the one on the left here. And you know, you can predict, I'm in quadrant 2, so sine will be positive, cos will be negative, and tan will be negative as well. Okay, and it says determine the primary trig ratios. I mean, I don't know why you need to do that, but sine 165, find out what it is, cos 165. You know, again, all we got to do here is just go back to this and have it do it for us. So just go to 165, and we'll just get all the ratios here. Okay, so there's everything for that one. I don't even think you need to write any of this down. This is just calculator work. All you had to do here is just plug in 165 into your calculator and get the answer. For the next question, so let's just let's move this one down a little bit. Okay. And we'll move that down a bit. For the next one, again, all you're trying to do here is figure out theta. So what do I notice about this? I notice in this question that theta is being rotated clockwise. Therefore, it is negative. Okay, so in this question, you know, it's rotating in a negative direction. If it rotated negative 180, it would have got all the way up there. So negative 180, take away the 50, I'm actually adding the 55 because I'm rotating the 55 like forward, if you like, gives me an angle of negative, what would that be, 125, which is the answer. Now, if you don't like that way of doing it, and I got to be honest, I don't really like that way of doing it, let's just treat it as a positive. What if it were a positive? What if theta were a positive? Then what I could say this. I could say 180 plus 55 is equal to 235 degrees. So if you rotate 235 degrees in a positive direction, you get to the same place where if you rotated 125 degrees in a negative direction. This is like saying if you turn to your left, you would be pointing the same way as if you did a 3/4 turn to your right, right? So like if you rotate in a positive way, you can get to the same place as rotating to a negative way. So the other thing you could say here is, how do you convert a positive angle to a negative one? You can convert any positive angle to a negative by simply taking theta and subtract 360. Equals theta as though it were as though it rotated the other way. Okay, so I do my 235, I subtract 360 degrees. Oops. I can't remember. What is it showing? I can't remember what the code is for the... I've typed it like 50 times. Okay, sorry, I can't remember it. Muscle memory, I forget. Okay, so anyway, you take away 235, take away 360, you get negative 125. There we go. Just need to stop doing it. You get negative 125. So what you're looking at in this question, theta is negative 125. That is the angle you are looking for. However, it should be clear that in every way, so let me just specify this, in every way, an angle of 125 of negative 125 is the same as an angle of 235, except in how you got there. But how you got there doesn't really matter as long as you arrive at the same place. Think of it this way. If you and your friend are both looking towards X, and she turns 125 degrees to her right, and you turn 235 degrees to your left, you are still both looking in the same direction. Okay? So, for this question, again, you can type, you can do it with a positive, you can do it with a negative, it doesn't matter. I will accept both. If you don't like negative angles, then simply use the positive angle. Get there in a positive way and use that instead. Right? So let me just demonstrate this quickly. So let's just go, let's just check, do it in a quick table. Let's say so over here, I'm going to work with negative 125 degrees. Over here, I'm going to work with 235 degrees. Okay? Sine. Okay, so let's work with sine first. So let's just make a new one. Okay, so I'm going to say alpha is equal to negative 125 degrees. And then I'm going to say theta is equal to positive 235 degrees. Okay, here's sine alpha, cos alpha, tan alpha. So let's just round it to 4 decimals. Okay, negative 0.8192. Cos was negative 0.5736. Tan was 1.4281. Okay. Now what if I'd done the same question but with 235 instead? Okay, so sine theta, cos theta, tan theta. Exact same in every way. So my point here is that you do not have to work with negative angles if you don't like them. You can just make the angle a positive by adding 360 or by rotating the other way to get to the same place, and you will get the same answer. So you almost never need to work with a negative angle in this unit if you do not want to. Of course, it's not that big a deal to work with a negative angle. You just count the other way. Okay, this last question is another one that's a guaranteed. You're just guaranteed to get it. So let's go through one of the. Well, we could probably do both, I guess. It's a long one today, but it's important. Okay, angle theta is a principal angle that lies in quadrant 3. So notice it tells me it's in quadrant 3. That's important. Such that 0 is less than theta is less than 360. Given each ratio, determine x, y, and r. Sketch the angle. Determine the principal angle and the related acute angle. All right. So in quadrant 3, x is negative and y is negative. Okay. So let's write down what we know. We also know sine theta is equal to y over r. So this tells us right off the bat, okay, that sine theta is negative 1 over 5. Now, of course, the 5 cannot be negative. So r is 5 and y is negative 1. Right? Remember, the r is never positive. X is, and let's just write r is always positive, okay, because then we never need to worry about that. Now, how do we get x, right? We get x by saying x squared, r squared equals x squared plus y squared, which means, right, so r squared, so 5 squared is equal to x squared plus negative 1 squared. Okay, and that tells us that 25 is equal to x squared plus 1, and therefore 24 equals x squared, and square root of 24 is x. So notice it says exact value. Exact value means you leave it as a radical. You cannot write, you don't take the square root and find it. Leave it as root 24. Okay? So determine the exact value of x, y, and r. So x is root 24. Now, remember I said before, r is always positive. So you square root it and you just take the positive. Not so with x and y. We don't know if x and y are positive and negative until we know more about the question. Since this is in quadrant 3, we know x must be negative. Therefore, we accept the negative answer. Okay, for r, you don't have to worry about this, but for x and y, you do have to worry about this. Okay, so x is equal to negative square root of 24. Now let's draw this. Okay, so let's draw a point, negative square root of 24, negative 1. Okay, there's my point. I'm going to draw a circle with radius 5. It should go through that point if I did this right. And you see that it does. Okay, I'm in quadrant 3. My point is over here. And now I can, your diagram should look something like this, right? So here's, here, let me rename this. This is A. This is the point P. And then you have O, which is the origin. And then you have angle AOP. Okay, and then we'll do segment OA and segment OP. Okay, we'll hide these. All right, now that's the angle. Sorry, let's just rename this to theta as well. Okay, so again, GeoGebra can tell you the angle, but of course I will want to know that you can do it without the computer's help. But let's just have this for our diagram so that we have it on here as a picture. Okay. Now, it says, sketch the angle theta in standard position, determine the principal angle theta and the related acute angle to the nearest degree. Here's where we're going to run into a problem. Okay. We know that theta is equal to the inverse sine of negative 1 over 5. We know that because that's what the question said. We also know that theta is equal to the inverse cos of square root 24 over 5. And it's also negative, sorry. We also know that theta is equal to the inverse tan of positive, this time, 1y over square root 24. Now, again, I'm making it positive because both of them are negative, right? So two negatives cancel. Now, again, I'm going to stop here because if you can see how to take it from here, I mean, I want you to finish this, and for practice, you can try B. But again, you're going to come across this problem where these three things give you different answers. I want you to figure out, what do you do with those three different answers? Which one is right? And how do I get the correct answer, which we know from GeoGebra is 191.54. Okay, answer that question, and you're in very good shape for what we're doing. If you're not sure about how to answer this question, get on the forum and try something. Give me something to work with, and I'll help you.